A very warm welcome to everyone. I'm Caroline Lindsay. Apologies for broadcasting from a chicken farm tonight, but the builders are in and working on my swish new office. So you might see that next time. We're thrilled that Dr. Lesley Hawson, veterinarian and equitation scientist, has risen as well, with the larks this morning in Australia. I think it's 5:30 a.m. there, to lecture us on the topic of how to recognise the good, the bad and the ugly in the world of equitation research. We have an hour's lecture with any questions at the end. So let's get started with the presentation. I hand you over to Dr. Lesley Hawson.
Thanks, Carolyn. And I'm so excited to be here, obviously, given that it is, as we call it over here, pre-sparrow fart. And I'm even more excited to be able to talk to you about the science as it's applied to saddle fit. I started becoming increasingly interested in the area of saddles and saddle interaction when I began my PhD with Professor Paul McGreevy and Dr. Andrew McLean way back in the dark ages of 2008. Little did we know how little we knew about this area. I'm sure most of you know that feeling well. 12 years on, and thankfully there are greater minds than mine doing a lot of research in this area, as it is in all horse science. It's not just equitation science. If you make the mistake of Googling horse science on Google Scholar, which I'll get to in a minute, you will find that there is work being done everywhere to do with our beloved equids. And this is a good thing, in my opinion. In this presentation, I hope to share some concepts and some tools that you can use to help you not only critique the papers in your area of expertise, but also identify the useful information that is almost always in these papers. Even if you don't agree with the overall thrust, careful dissection of the paper will lead you to find there's almost always little nuggets of useful information that you can take away into your daily practice. In this way, you are optimizing the knowledge that we have now at our fingertips. Never before have we had so much access to the knowledge that is around the world, thanks to the marvels of the internet. To be clear at the start, I am talking about papers that have been peer-reviewed by other scientists in order to be published in scientific journals, as these are the source of evidence-based practice in all fields. So what do you do currently when you're faced with an unfamiliar problem in practice? In my opinion, the first step is to challenge yourself. One of the quite confronting issues that we have to accept is that we all have inherent biases in our thinking. This is perfectly normal. Humans are wired to make quick snap judgments. That is how we survived. We tend to use neurological shortcuts to do this. They're called heuristics. That's spelled Heuristics. Unfortunately, they can lead to a decision that does not take into account all relevant information when you've got time to make a deeper dive into your problem. And that is why we make so-called mistakes. It's the basis of the phrase, I'm only human. But ultimately, they do lead to bias in our decision making. In this slide, I compare the traditional approach that most of us learnt as we grew up to an evidence-based approach. An evidence-based approach does accept that personal experience can be misleading. The advantage of using scientific approach to looking at problems is that it forces the person to go deeper and avoid shortcuts using our natural tendencies. One of the things that I find extremely interesting in science, particularly to do with horses, is that there tends to be an extrapolation of physiology from other species that can be wrong for horses. Reading literature, however, requires a lot more than common sense to evaluate the evidence. You have to have some basic tools in your toolkit, and I'm sure as saddle fitters, you understand that concept. If the only tool you have in your toolkit is a hammer, all the problems look like nails. So what is evidence-based practice? This is a definition that I've been using to talk to practitioners in other fields about evidence-based practice. It is taken originally from the medical field and has gradually been incorporated into many, many different areas of practice, including veterinary science. The word explicit is the most important word in the definition because it forces us as practitioners to be able to explain how we choose one solution over another and how and why the decision was made. Most importantly, we can justify our decisions should we be subject to external scrutiny. It forces us to be explicit and methodical in our assessments and solutions. It makes us accountable to the horses, their owners, and ourselves. Is what makes us professional practitioners. So why should we pursue an evidence-based approach in saddle fitting? Because we need the most relevant information at the right time. It is impossible to keep up with all the developments across the board, however. Instead, practitioners need to be able to efficiently source and evaluate up-to-date information that is relevant to the case in hand, almost information just in time, or if you like, solutions just in time. We must be prepared to identify and replace outdated and obsolete knowledge while incorporating it into our previous practice. I know that a lot of saddle fitters deal with having to manage client expectations. Evidence-based approach can assist. Most of us will make the mistake, and certainly I did in veterinary practice, of going too far and saying, well, so-and-so said this and this paper found that to our clients. Just be aware that they might not be along the journey as far as you are and may just start to roll their eyes back in their heads. You do need to be able to communicate your decision making as well in a way that is non-threatening. But I think that's another presentation, Carolyn, and certainly I'm no expert in that. It's a whole field in itself. Today we're talking about evaluating and using evidence available to us in the scientific literature. The first thing that we need to recognise is that evidence comes from peer-reviewed research. Peer review means the paper has been submitted to independent scientists who have proven their expertise by publishing papers previously in appropriate recognised journals. The reviewers do not get paid to do this job, and I can assure you, as someone who reviews quite a few papers, it is quite onerous. It came as a bit of a shock to me as a PhD student that I was expected to do this as part of the responsibility of being part of the scientific community. As time wore on, I realised that being a reviewer is a very privileged position because you have the opportunity to influence the outcome of the paper without actually having to do all the hard work of doing the investigation. The reviewers might not get paid, but they do sometimes be given access to journals to do their own research. that are behind paywalls or a voucher to publish with the journal. But you need to understand they get these incentives whether they reject or accept the manuscript after they've reviewed it. So it's more a acknowledgement of the reviewer's time rather than an incentive to accept the manuscript. The process is quite rigorous, and the paper will usually go through several iterations before being accepted. The reviewers send back a comprehensive document explaining what they think is good in the paper, but also critiquing where there's problems. And like all things, it's not infallible. For me, I find if I'm very familiar with the paper material, like the research area, it still takes a day to properly review a paper. If it's an area that I'm not familiar with, it may take up to a week because I have to go and do some reading. On this slide, I have put some points to remember. Be kind when you read journal articles. The researchers will have put innumerable hours into the work. Most research articles only have 3,500 words to work with, so they have to cut down the content. And English may not be the researcher's first language, so sometimes to read it can be a bit convoluted. The peer review system is not perfect, but it's the best system we've got. I think this explains a little bit about the process of how and why peer review work is the go-to if you want to get as close as you can to what is really happening in the real world. However, not all research is equal. As you will come to realise, there is a whole lot of different types of research, and this pyramid gives you a concept of the weight that is given to different types of studies and research work. At the very top is systematic reviews, of which the most famous is probably the Cochrane reviews, and they're basically medical science, although I think they're going into other areas now. Now, as you go up this pyramid, the evidence has what we call more power because it is more likely to reflect the population of the subjects that you're studying, often just through sheer numbers, if nothing else. Research designs further down the pyramid produce results that are less transferable to other populations, but may be applicable to certain types of patients. Descriptive studies record observations. So if you have a case study, the most you can say is that this happened, this is what we observed, but it is not possible to explain causation or make conclusions about treatment effects. Essentially, exploratory studies such as case studies or case series, where there might be a whole series of cases about a similar event occurring in patients, are used to formulate hypotheses to be tested. Case studies and case series are getting increasingly difficult to publish because the thinking is that they are not of sufficient weight. The next thing is explanatory studies. They compare at least two groups, experimental or observational. Literature reviews, often it falls on the newly wedded PhD student to do literature reviews, are a drawing together of the literature in a certain area and analysis or comparison between the two. They presuppose there is enough good research out there to make it worthwhile, and that is not always the case. Then we get to the meta-analysis, such as the Cochrane reviews, where all studies with similar enough results and subjects are aggregated and analysed. So the take home is that evidence that is at the bottom of the pyramid is less weighty. It doesn't mean you can't use that information, and certainly custom and practice is we do use expert opinions out in the field, but you just need to consider them with caution. And I would urge you to always drop back into the research if you want to follow up on things that just don't quite gel for you. So I apologise about the slide. It's literally a screenshot. I did a demonstration search on Google Scholar. Google Scholar is the easiest and most accessible search engine for people that don't have access to the databases through the universities or can afford to cough up the subscriptions. So Google Scholar is one of your apps. If you use Google as your main search engine and you go into the apps such as Google Calendar or Gmail or whatever you use, if you scroll down a bit, you'll find Google Scholar, and then you can put it as I've put it as a sub-tab under my journals and articles on my book bar. So I go to, as you can see, it's on the left-hand side, and so I go to it a lot. I've just put saddle plus horse. If you put plus in, that means it's going to combine the two. Otherwise, you get some very erudite writing on bicycle seats, but not really of my interest if you just put saddle in. I like it because you can set the time frame, and it provides links to full documents when they're available on the right-hand side. If you click on the article, you can get access to the abstracts, which I'm going to talk about in a tick. There are other free sources to access full articles, but just be aware, I think some of them are a little bit questionable in terms of legality, in terms of who owns the copyright. Nevertheless, I've put them up there. When you're looking at articles, time frame is important. Any research that is older than 5 years begins to be questionable in terms of whether it's up to date. And any research that is older than 10 years is virtually obsolete unless it's covering an evergreen subject. So you need to use anything older than 10 years with caution. Do be wary of using the aggregators that I've mentioned here. You need to always go to the source if you're going to make decisions based on what the research is covering. I just wanted to touch on the structure of scientific peer-reviewed articles. So there's this cycle that anyone who's using the scientific method will use. The first is, of course, you have an observation or a question. So this is where field work, clinical practice, case studies all come in. They're basically there to generate the question. From there, you might develop a theory or a hypothesis that how something might work. Then you want to test whether your idea about how something might work with an experiment. Just be aware that we design experiments to prove that the phenomenon we're trying to investigate didn't happen by chance. Just pop that concept in the back of your mind. Good research always results in more questions than answers. The aim of scientific research in the modern day is not to present a world-changing discovery, but to incrementally build on previous work. That's why in horse science, you might find research that looks bleeding obvious. I always smile when I see comments on Facebook when people say things like, well, duh, everyone knew that. The problem is, unless you've got evidence that everyone, quote, thinks is measurable and identifiable, then you can't really rely on that. My saddle pad survey that I did was an example of that. We knew that nearly everyone used some sort of layer between the saddle and the horse, but we had no measurement or proof that that was the case. It was all observation. Nor did we know the reason why people were using different sorts of saddle pads. So even on Google Scholar, you will always get access to an abstract. Abstracts are a summary of the research. They are kind of like the blurbs on the back of the books. And just like blurbs, they do not give the full story. Quite often, it is the detail buried in the paper itself that provides the real answers. That's why I advise, wherever possible, get hold of the full article. If not openly published, you might need to put the hard word on someone you know who has access to the journal through their university or professional association, for example, Beaver. Sometimes you can just email one of the authors and they will send you the copy of the paper. All articles have details on who is the contact person and how to contact them. It's usually marked by an asterisk. So as you can see here, the Marie T. Dittman has got an asterisk against her name. And if you go somewhere on that front paper, they'll actually have how to get in touch with her. And it's very rarely you will find an author who's not absolutely excited to share their paper with you. So the next step is this threshold question. Is this paper CRAAP? I have to thank a podcast that I listen to a lot called The Safety of Work, and they put me onto this resource, which I think is excellent. It's called the CRAP test. Sarah Blakesley was a librarian at California State University, and she developed these guidelines in 2004 when she was looking for resources for her students to help them get across how to evaluate information sources, particularly from scientific sources. So you can use this as a starting point. Reading academic papers is a skill that improves with practice. The CRAP test will help you decide if the paper is worthwhile. So the first part of a paper is always the introduction. I'm going to use Dittman et al.'s well-written and well-designed paper, Feel the Force, Prevalence of Subjectivity, to assess saddle fit problems in Swiss riding horses and their association with saddle pressure measurements and back pain. It's quite a complex paper, but it does follow the model used in scientific papers very well. So the role of the introduction is to cover the preceding research and put this research into context. Certainly, if you're just starting out down this journey, I would recommend reading introductions carefully because you can find out a lot of information about your area of interest. It's also worth looking at the reference section to see if there's any other papers you are interested in. It also answers one of your questions in the CRAP test. Is this paper and the knowledge it's covering current? The hypothesis will also introduce you to the question the researchers are looking to answer, and they'll usually state their hypotheses. So going back to the Dittman paper, after reading the introduction, we can answer the first part of the CRAP test. Now the bad news. I usually do at least 3 reads of a paper that I'm really interested in. And it's this first one is the CRAP test read. I am not going to waste my time reading papers that are poorly designed or not covering current information. So the first question is currency. This paper is published in 2021, so it is current. In my opinion, some of the references are a bit old, but that may reflect the paucity of research in this particular area. It's relevant because I'm very interested in the connection between saddle fit, back pain and horses, and what can be detected with the electronic saddle pads. So authority. This is a tricky one. You need to understand the basic system of how papers come to be written. Usually, unless the researcher is an absolute deity like David Mealaw, the grunt work for the research is performed by a PhD candidate. They're essentially the engine of research in the modern world. They are usually listed as the first or second author with the real power behind the throne, the senior researcher, listed last. Usually there is one statistician listed as which you can spot when you look at the papers published by them. So to do that, you can just drop their name into Google Scholar and it'll generate all the papers that particular author has written. And the statisticians invariably cover a really wide area of research because researchers contract the statistician to help them out with the data analysis. If they're anything like me, they have to rely on them very heavily. So, authority. It's a mixed match of what journal are we looking at. So the Journal of Equine Veterinary Science is a well-respected journal with what we call a high impact rating. That's an algorithm that is used to tell you whether the journal is well respected and is known for publishing high quality papers. All the authors listed are associated with a reputable university, which has a long history of good research in this and related areas. All authors except Hungabola, published other papers in the same area of research. Makes me think that this person is probably the statistician. Weishaupt is a respected and prolific researcher. And finally, there's an ethics statement and financial disclosure statement present. So there's no evidence of conflict of interest. So far, so good. I think this paper does pass the CRA part of our test. The next question I usually get to in my second read through. What is this paper really about? This is where I'll make notes, especially taking notes of abbreviations that are used. So the custom and practice is that the first time a descriptor is used, and so in the Dittman paper, you'll notice they use HMP, I think, and that's for the horse and rider combination. Do make a note of it. I am very lazy with this, and I'll often be reading through the paper the second time and get to the results section, and they'll have all their abbreviations there, and I won't have made note of them. And I invariably have to go back and reread the methods and methodology section to work out what the earth they're talking about. I've finally weaned myself off the printed page and I make my notes on the PC. So this is the handy hints part of the presentation. I often just cut and paste text from the paper into a Word document. So I'm an enthusiastic user of the snip tool in Windows, so I can put actual figures from the paper directly into my summary document. I often note references that have been used and I might not be up to date or familiar with them, and go and find them to double check if what the authors of the primary paper have quoted from the research. Sometimes things get lost in translation. If the authors have quoted a paper that is not the original research, it's a good idea to go back and look at the original research. Again, they're talking about biases and heuristics that humans use. It's kind of natural to cherry pick or choose information from previous work that supports your statements. So just be aware that can happen. The other thing that can happen is they have simply restated someone else's quotes, and just like Chinese whispers, this results in a dilution or misquoting of the original research. An excellent example of this is the Dunning-Kruger effect, which you can see the meme at the top right of this slide. You may have seen this coming up, and boy, it rings true when you first read it. But the bottom graph shows the actual data from the original research, and you can see that it's completely different. There is still a tendency for people who don't know what they don't know to be more confident than people that do know. Sadly, that's the curse of knowledge. The more you know, the less sure you are. Now, well, certainly that's how I've found my journey through science. So the step in this second read through is be critical, but don't judge just yet. So now I need to just go into a little bit of detail about the design of studies. The researchers must state the design of their experiment clearly so that anyone so inclined could repeat the experiment. That's the bottom line. Because the design of the study influences how powerful the study is. So what is this mysterious power we speak of? It's essentially the probability of detecting that the actual phenomena found by the researchers really exists and is applicable to the whole population and not just the sample of subjects used in the experiment. Essentially, the bottom line is more powerful studies are more reliable. Now, the problem we have with horse-related research is that we may be ending up measuring small or subtle changes. So that means we have to have bigger samples. In my research, it could never be less than 10 to have sufficient power. And rule of thumb, if you have over 100 subjects in your sample, the size of the sample ceases to matter so much. The rule is more subjects equals more power, but horse studies are so expensive to run because horses are big. They're not rats. They cost a lot to feed. So most researchers are trying to minimize the number of animals that they use. We're also required under animal ethics to reduce the number of animals being used in experiments. Those of you who are already reading papers will observe that much horse research, especially veterinary-related research, is based on very small samples, often only 3 or 4 horses or a small number of steps. That is why we must always be open to new knowledge as technology becomes more sophisticated and more research is conducted. So you'll note that I've said the power of an experiment impacts on the likelihood of making type 1 or type 2 errors. Type 1 errors are when you wrongly reject the null hypothesis. The null hypothesis is that the phenomena you are measuring is happening due to chance and nothing to do with what the experiment is doing. So you think you are a fantastic researcher who really did find something new and exciting, but really, no. Type 2 is the opposite. You accept that it all happened to chance when actually there was an experimental effect and you missed your shot at fame. Fortunately, the reviewers will usually sort the statistics side of it out before it gets published, and glaring errors are usually picked up. Not always, but usually. The methods and methodology covers how the experimenters, the researchers, are going to test their hypotheses. Again, just to remind you, it has to be written in a way that would allow the experiment to be replicated. As I mentioned before, I inevitably gloss over the M&M section and in my first read through, and then realize I actually have to go back and read it properly to understand what the heck went on. Just on that note, Control F, if you're using Windows, is your friend to find when they first used those dreaded abbreviations. So this is where these questions are asked. The notes I took from the Dittman paper were that there were it's HRP rather than HNP for horse rider pair. That makes sense, doesn't it? So there was over 100 subjects, so it's got good power. It was a convenient sample, so that means you've got lots of variables that you can't control. The saddle and back pain scoring was subjective, The electronic measurements were done with the Pliant system that has been well documented, although it does have limitations. Note that the actual measurements were based on trot in straight lines, which was 20 seconds only, and canter on circle, each rein 20 seconds only. So they actually, even though they had a lot of horse rider pairs, each pair was only measured all up for about 80 seconds, I assume. And that's because of the data generated by the electronic saddle system. Those of you lucky to have enough to analyse data from these electronic systems will know that the sheer number of data points that are generated is huge. You end up with a completely unmanageable spreadsheet. They got around this a little by zoning the areas under the saddle, which has been done previously, and their categoric variables were fit problems and back pain, and they used a variety of statistical analysis, which comes to the invariable thing of stats. Please don't switch off. We can get through this together because I am not a statistician. The first part of the stats is usually descriptive stats. This is just to give the reader an idea of what the results looked like, but the main thing is you cannot draw any conclusions from descriptive stats. It's just to give you a snapshot of what they found. You can tell I'm interested in this because I'm glossing through. Confidence intervals, if you see the letters CI, give the researcher an idea of how likely the mean of the group they experimented on represents the mean of the population. More subjects in the sample make the researchers more confident that what they're seeing is really true. And usually you'll see on these graphs these dots and lines that's in that meme, and the lines show you how at the confidence interval. Don't worry about it too much. I just wanted to cover it because CIs will pop up in your reading. What is more important is to take note of the p-value. So the p-value is the probability of a finding occurring by chance alone. Custom and practice in biological research is to make the p-value 0.05. So that means that there is a 1 in 20 chance that the result was due to luck. You want your results to be less than, to have a p-value when you do your statistical analysis of less than 0.05. So with those tools in hand, we can have a look at the paper in terms of the results they found. The main takeaway that I got was the distribution of pressure might predict back pain more than overall pressure, but there is no correlation between back pain score and the highest mean pressure. Now, we're going to talk about figure 3 because it does talk about their findings in both graphical form and nice pictures, which I like, but it also talks about their findings in terms of p-value. So these were just the summary notes that I put on these general findings. You can see that I've already asking questions. Consider COM impact, that's centre of mass. One of the mainstays of my thinking is that the rider's centre of mass must align with the horse's centre of mass if you're going to have a harmonious and less biomechanically wearing impact on riding horses. So that means the saddle's prime role is to provide a stable platform for the rider and horse to align their centre of mass. So that's why that came up. Sorry, I'm getting on my soapbox. So this is a screenshot of figure 3 from the Dittman paper. If you remember, if you've had an opportunity to read it, figure 3 is a series of measurement summaries using the zoning system that they elected to put their measurements into for each of their hypotheses. So in this case, the hypothesis is that channels less than 6 centimetres wide will have more pressure recorded in the sensors situated closest to the spine. Forgive my typo. This is what the data did indeed show. But the important thing is, at the top next to the coloured square is a summary that says the narrower the panel channel, the higher the ratio. And it was confirmed for all gates, P equals 0.009. So that means the p-value is less than 0.05. There is a less than 1 in, much less, it's nearly down to 1 in 100 chance that this pattern that they observed from the pressure was due to chance. So I'm happy to accept that this pattern that they observed with smaller channeled saddles is indeed factual. Let's have a look at the next one. So the next one I want to talk about is balance. The hypothesis is that the area under the front of the saddle will experience higher pressure in saddles tipping forward than saddles that are balanced. And the area under the back of the saddle will experience higher pressure in saddles that tip backwards. In this case, if we go back up to where the results from the actual paper is, next to the coloured square, we find that the p-value is greater than 0.05. So the hypothesis is rejected. There is a logic flaw, in my opinion, in how this is done. I'll be interested in any feedback. And it goes back to my obsession with centres of mass. So the last one is angle and width of the tree head general. So what was the researchers' hypothesis? Was it proved? And why do you think they got this result? The next phase of the paper is always the discussion. This is where the researchers will put their interpretation on their findings. What worked, what didn't, and how it all relates to other research in the field. This is always where they must be critical of their own research and ask questions that have arisen out of their research. And this, dear reader, is where you often find gold. So in the Dittman et al. Paper, we certainly did find saddle fit problems were high. I don't find that surprising. It's repeated in other areas to do with horses. If you look at the lameness work, it's the same. They accept that the research is field research, so you cannot control all the variables. The subjective nature of saddle fitting made it difficult to measure, as I'm sure you all know. I'm curious why they didn't use more than one assessor. Again, it's availability, cost, time. And I'm also curious why they didn't use algometers to measure back pain, as that's quite a well-accepted technology for putting a numerical value on back pain in horses. The differences in saddle design seem to be to help the rider, not the horse. For example, the finding that the steep panels in the dressage saddles may help the rider but cause discomfort for the horse, and the narrow waist for show jumping saddles is more stable for the rider when jumping, even though we know that they can increase the pressure T10 to T13. And we know from the excellent research that's come out in the last few years that if you reduce the pressure T10 to T13, you get better biomechanics for the horse. Interestingly, in this research, only 15% of the saddles showed pressures that were a mean pressure over that has been suggested in previous research to be associated with back pain problems. But in this paper, nearly 1/3 of the horses showed back pain. So there's something missing there. And then one of the big takeaways and again, I'm sure it's no surprise to saddle fitters, that the distribution of pressure is more important in terms of comfort for the horse than overall mean pressure. Now, the last part of the paper is, well, second to last, is the conclusion. So that links back to the original problem posed and therefore the hypotheses. The conclusion should be where the authors restate their new insights into their findings, but they must not introduce new information. They can only use what they've already covered. Remember, they've only got 3,500 words to do all of this. So often the conclusion is the hardest part. And you should come away from reading the conclusion of understanding where this research fits into the context of the body of knowledge, and with any luck, some takeaways for applicability in real life. Not always, some research is just pure research, but increasingly we researchers must work at making our research useful for people to A, understand, and B, be able to apply in their work. That's the responsibility on the researchers if we're all going to pursue this evidence-based practice. So, flicking back to the Dittman paper, lots of subjectively assessed saddle problems. Pressure distribution contributes to back pain more than absolute magnitude of pressure, which is an important finding. And the electronic saddle pressure measurements can provide quantitative information that could augment subjective saddle fitting. I find this extremely interesting because it's exactly parallels what we're finding in lameness identification in horses. Those of you who share my interests in all things horse will know there's been a quiet revolution going on in the lameness area where we now have electronic tools that will accurately demonstrate where there is a gait defect. Last part of the paper is the reference section. All facts that are quoted in the paper should have the origin referenced, and part of the job of the review is to say, where did you get this idea from? Sometimes things are just referenced because someone stated something as gospel 50 years ago, and no one has actually gone back to check what was actually said. That's why things in science change all the time. Again, rule of thumb, any reference older than 5 years is to be read with some caution, and certainly anything older than 10 years is probably inaccurate and probably outdated. So does this paper pass the CRAP test? In terms of, did the researchers actually do what they said they would do? Is the sample they used representative of the test population? Perhaps not. In the Dittman paper, as it relied on people responding to an advertisement and having the time to attend the testing, so there might have been bias in the actual sample selection. Was there enough test subjects to draw representative results? Yes, given this is horse research. Does the discussion and conclusions match the statistics and the other findings? Yes, they do. My final tip for practitioners is to put the knowledge into a format that works for you. Once you've decided that the paper does pass the CRAP test, you need to go back and read it again so that you can put the knowledge into a format that works for you. The simpler the better, so you can identify the takeaways that you want to use. If you've got major questions, you can always ask the correspondence author for answers or exploration of the problems. Notes on the right-hand side is just my take home from the Dittman paper. This is essentially what I've distilled the paper down to, and I have got questions. I mean, why was the back pain score lower in rocking saddles? I need to understand that more. But it was interesting that back pain was not associated with narrow waist, number of fit issues, other fit issues. And the other one, which I really liked because of my saddle pad interest, is how that the sheepskin pads consistently dropped the overall mean saddle pressure. So, in conclusion, unfortunately, particularly for these complex papers, and while you're learning, it will take 3 read-throughs to really understand the paper. Use the CRAP test as a filter to decide whether you're going to spend any more of your valuable time on a paper or not. In terms of statistics, you do not need to be a statistics guru to read scientific papers. You just need to have an understanding of the implications of the research design, the sample size, and therefore the power of the study, and watch those p-values. One of the things I have learned is don't panic if it takes a while for a paper to sink in. I'm increasingly a fan of soak time. In other words, read the paper through quickly, decide whether it meets the CRAP test. You might start on your second read through and go, oh my goodness, I think I need a break. That's fine. Go away, come back to it sometime later, and you will find that your amazing subconscious will have worked away on it, and you'll come in with a new view on it. And finally, ask for help. This is a picture of one of my dogs, Dixie, giving me a hand trying to digest the complexities of figure 3 in the Dittman paper. I will be providing a copy of these slides to Carolyn, and so there's quite a few links there that you may find useful. Can I just encourage you to not be frightened of scientific papers? There's always nuggets of important knowledge in there that you can use and take away, even if you just take away one thing. I mean, my takeaway from the Dittman paper, apart from all the rocking and that sort of thing, is sheepskin pads, good. That's it, Carolyn, from me.
Well, thank you very much. You made that rather painful subject rather painless and entertaining. There aren't many questions. I think you covered just about everything, and they're deep in thought. Dr. Anne Bondy from the Saddle Research Trust would like us to clarify that the SRT is not an aggregator of scientific research. What did you mean by aggregator?
Oh, sorry, Anne. I really just looked at it that I could go there and see papers. It was aggregators in the electronic form. That's their business. So I was probably a bit loose with the terminology. I will make the change in the final version, Anne. So, my apologies. So aggregators are, if you look at thehorse.com, they tend to stay up to date with papers that are coming through, and they'll write articles and very helpfully put links to the articles, so you can use them as a portal into finding articles. There are, I think, the Equine Documentalist might be a more traditional aggregator. There are sources around the place that tend to monitor the output of that's coming out in the scientific community and put them in one place so that you can find them. That was my version of aggregator. Sorry, Anne.
No, I was the one who asked the question about what an aggregator means, not Anne.
They basically aggregate the articles and knowledge into one place, rather so you don't have to search for them.
Right. More comments. This was very helpful, and this was very helpful to know how to look for more reliable information. Thank you. And that was really useful. Thank you. And very many thanks. Really useful and informative. And I'd just like to say that as a PhD student, 1 year into my program, it is so tempting, as when I'm doing my research, to embrace literature which validates my beliefs and perspectives. The bias is so strong, even though I've been tasked to perform systematic digital searches and include or exclude according to my structured research questions. So it's really easy to get excited when I read something that agrees with what I believe. So I'm more tempted to quote it.
Well, when you come to write up your papers, you'll find, because you've only got 3,500 words usually, it's so tempting to cherry pick, you know, and just say, oh, I'll use this to support my statement, not account for the fact that there'll always be another side to things.
Yeah.
And the main thing I found from doing the PhD process is I went from not knowing what I don't know to knowing I don't know. It's all a bit depressing, really. So I wish you well on your journey, Carolyn.
Thank you. I'm really enjoying it so far. I just wanted to mention about others might want to go to the academia.com website because it is so useful. There is a lot of free stuff there, and there's a lot of books. They may be a bit old, some more than 10 years old, but there are a lot of textbooks there. And if you just keep searching on the website for a couple of days, it will give you a 50% discount offer. So this brings your database down to £29 per annum. So that's a really good place to start. And I've found that a lot of the papers that I've been looking at in my PhD research, they're on there in full. And just to say, completely agree with Lesley that you shouldn't be reading abstracts and quoting those. If you're going to quote some research, it's well worth getting hold of the paper and looking at the methodology. And yeah, me too. I love the introductions. There's some fantastic nuggets there. And I love the discussion parts of these papers. So it's all good. You just got to know what's good and not so good.
So, Carolyn, can I just say to the audience, now that you've reminded us that you're doing your PhD, if you can't get a paper, you can pester Carolyn to get it through her affiliations. People who are still involved in the university sector are your friends. Because they can access a lot of papers that those of us who've fallen off the path can't. But I will put the academia link in that slide, Carolyn, so that when you get the final document, we'll put it all together.
Yes, and I feel a research summit coming on. We were having great fun with Jochen and Maria Howring and Bradley Whale, which we're coming back to soon. But I think we need a research summit with some big guns talking about research. You included, Lesley. So
I'd love to spend some time with the researchers who conducted this paper. It's so comprehensive, and it's worthwhile going into their supplementary material that is also available, because I only glossed over it, but there is some really deep stuff. And as you've found, Carolyn, reading these papers is a skill, and just like all skills, the more you do it, the better you get. But I was very excited to find the crap test, because I've actually got in my library, my electronic library, the useless file, where I've tracked down these papers and finally got them, found the treasure, and then started reading them and realized that they are useless. And so they go in the useless file.
I've also found that there's some excellent student papers presented at conferences, because they have typically put a lot of study into their thesis, and they're not paid for this apart from getting a good or really great mark at the end. So I find some real nuggets with those, some real nuggets in there.
The ISIS proceedings are always very interesting reading. that are made public, usually a couple of months after the conference. So I commend them to you. And we get more saddle fitters as members of the International Society of Equitation Science, just to clarify, not the terrorist group. We welcome practitioners as part of it, because even though we've been hanging around with horses for 5,000 years, the actual science as applied to horses is still really only at the toddler stage. We might have come out of the infancy stage in the last couple of years, but as far as I can see, we're just beginning.
Yeah, and I noticed from a literature review that I did recently, which was marked, is that equitation research seems to attract a lot of technology. So they're out there on the cutting edge with the technology, but there are other aspects of the research, such as the calibration of the riders, which is almost impossible. Saddle fit for the rider is not, well, we're using generic seat design. So, you know, for all its faults, it's up there with the technology. So,
well,
and that can only get better.
As fellow researchers will attest, I can tell you the space between the horse's back and the bottom of the saddle is a very, very challenging area to measure and control. You've got humidity, you've got movement, you've got heat, you've got fast changing high pressures. I used to just mutter to myself as the technology was break down, it's not rocket science, it's not rocket science. But in terms of the actual physical parameters you're dealing with, it's pretty damn close. The stuff that's been going on with the lameness locators and the revolution that's occurring in that area, I think will bleed over into other horse areas too. So that's exciting. What I want, if anyone comes up with an idea of how we can actually measure the pressure between the bit and the mouth structures, we talk about being between the saddle and the back, a difficult environment. How on earth can we measure that pressure? Because we talk about rag tension, but really that's a proxy for what's actually going on in the mouth. So anyone got ideas, just let me know. I'm up for it.
I think the more we learn about ethogram, the more feedback we can get from the horse. That's pretty much like them filling in a questionnaire. If we can learn what comfort for them is, because I think we can get quite technical with the minutiae here and the detail, but surely we should be looking at the horse perhaps as much as the data that's generated.
I guess the issue, I've been watching the work with the ethogram, and certainly it plugs in very well with the more traditional approach of looking to the horse for the answers. I would still like to see increased validation between the observations that's made between the ethogram and what the horse is experiencing. For example, one of the interesting presentations I understand at ISIS was that horses that appear calm and not showing any external reaction can have physiological parameters that would indicate they're experiencing quite a deal of distress.
Yeah.
So we do have to be careful correlating. And then there's the whole issue of cortisol, which is getting more and more vexed. So watch this space. We're toddlers. We're still toddlers. We haven't even reached proper childhood, I think.
We're trying though. We're trying. And I think definitely a whole lot more work is needed on the rider, which is what my PhD is focusing on. We keep blaming the horse for these shortcomings, and we keep wanting to improve the horse. Just get the rider loading well.
I mentioned my obsession with centre of mass alignment, but also where I sourced the crap test from. And one of the, because I have another sideline interest in safety, and it's becoming increasingly mainstream. And one of the 5 principles of the new view of safety is blame does not solve anything. And if you take that and apply it to the horse rider context, blaming anyone does not solve anything.
Yeah.
You don't ask why is it happening, you're asking how it happens.
Yeah. Yeah, and I think we've got to get better at evaluating, definitely, which is what I use the research for, you know, little nuggets of, oh, let's look at this or let's look at that. A couple more comments. We have from Dr. Anne Bondi. Thank you for your clarification. The Subtle Research Trust translates and disseminates key messages from science for the lay audience, which is extremely helpful. And she says,
very important.
Yeah, very. Thank you so much for the great translation. And we have really useful. Thank you very much for getting up so early for us. Yes, thank you. You clearly don't need the beauty sleep, Lesley, like the rest of us.
Filters, my friends, filters.
And Dr. Anne Bondi says, great evening, thank you. So,
lovely.
Yeah,
thanks, Anne.
Really enjoyed it. Thank you.
Thank you, everyone. Enjoy your days. Don't overwork your horses on the hard ground.
Definitely.
Yeah. No, I vetted endurance rides because I'm slightly mad, perhaps. And the incidence of concussion lameness is a little disturbing. Yeah. So just be careful. Bye-bye, everyone. It's been great talking to you. Have a great night, everyone. And thank you so much for spending some time with me.
Thank you, everyone.